Hello everyone. The title of this video is Finding X-Intercepts and Y-Intercepts. Every example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and I'm in their Algebra and Trigonometry text, section 2.1, titled The Rectangular Coordinate Systems and Graphs. And I'll be working under the objective with the heading Find X-Intercepts and Y-Intercepts. Alright, so the examples I'm doing in this video are taken from the examples or the try it problems from the reading in this section, or from some of the even numbered exercises at the end of the section that are related to this particular objective. I will also have timestamps in the description below for when each of these examples begins in the video. I also request that when I start a new question, pause the video and try to work it out yourself first before watching me do it and then comparing. Because if you're just watching me do these things and not practicing yourself, chances are you're not going to learn all that much. Alright, so all the examples I have written out on paper. Again, the heading is Find X-Intercepts and Y-Intercepts. And our instructions for each question in this video is to find the intercepts. And when they say find the intercepts, they mean both, right? The X and Y intercepts of a graph. So find the intercepts of the equation and sketch the graph. So first let's talk about intercepts. Alright, so X-intercepts, start with those. X-intercepts are points of a graph in the XY coordinate plane or the Cartesian coordinate plane. They're points of a graph that are on the x-axis. Okay. And if you're a point on the x-axis, that means that your y-coordinate must be 0. Right, so that's how we're going to find x-intercepts. We're going to let the y-coordinate be 0. Right, so replace y with 0 in any equation we're given with x and y. Replace y with 0 and solve for x. That's how we're going to find x-intercepts. And then in a very similar fashion, we'll find y-intercepts. So y-intercepts these are points of a graph, that are on the y-axis. Right, that was the vertical axis, the one going up and down on the xy coordinate plane, right, the Cartesian coordinate system. And if you're a point on the y-axis, that means that your x-coordinate must be 0. Right? If the x-coordinate of the ordered pair is 0, then you're on the y-axis and you are a y-intercept. So that's how we're going to find y-intercepts. I'm going to replace x with 0, right? The x coordinate with 0, and solve for y. And it's really that simple. And in this particular video, these are the only points we're going to really need to find to be able to graph, sketch the graph of the rest of the equation. Because in this video, every single equation we're going to see is going to have x to the first power, y to the first power, no other powers of x and y, no special symbols, right? No square root symbols, no absolute value symbols, nothing like that. No variables in denominators, right? Nothing like that stuff. Nothing special about it, really. And if that's the case, what we're going to have here is linear equations. Every single equation in this video is a linear equation. The graph will be a straight line. Alright, so all I'm going to need to find are 2 points. So one of those points is going to be the x-intercept of the line, and the other point will be the y-intercept of the line. And then I'm going to do a rough sketch by hand. Now if you have graph paper, that would be ideal, but I'm going to do the best I can with a hand drawing, and then I'll show you a website with a free graphing calculator on it that you can use as well to verify your work. Alright, so the first equation we're given is y equals negative 3/4 times x plus 3. And we're asked to, find the intercepts. So first, let's go with the x-intercepts, right? Or x-intercept, right? If it's a linear equation, it can have at most one x-intercept. So remember, we're going to let y be 0, right? The y coordinate, the second coordinate of the ordered pair, be 0, and then solve for x. So I put in 0 for y, right? So this left side of the equation becomes 0, equals, negative 3/4 times x plus 3, and then I solve for x. This is a linear equation, right? You got x to the first. So I get every term with x on one side, terms without x on the other. So I'm going to subtract 3 first. Give me negative 3 on the left, equals negative 3/4 times x on the right. And then I would multiply both sides by negative 4/3. Okay, and I'm going to leave that to you in all this, but if I multiply both sides by negative 4/3, the left side is just going to be 4, and then we have x. And multiplying a number by its reciprocal gives you 1. So there we go. Right, so the x-intercept is this ordered pair, this point that I'm going to plot on the coordinate plane. X is 4, right? The x coordinate 4, comma, and we already said the y coordinate must be 0, right? If you're on the x-axis. So 4, 0, and I'll put that in a nice box. That's one of the things that the instructions are asking me for. Right, so there's the x-intercept, and I'll plot this. Let me go to a separate page here, and I'm going to make a rough sketch of the xy plane, right? So remember, the horizontal axis is the x-axis number line, right? And then the vertical axis that meets this at a 90-degree angle. There's the y-axis. And to plot this point, right, I go to 0 in the middle here. You go to positive 4 on the x-axis, and then 0 on the y-axis means you're on the x-axis, and that would be this point right here. And I'll label it for this first question. There's the point on the plane that has x coordinate 4 and y coordinate 0, right, the x-intercept. All right, and then again, very similarly, for the y-intercept, you're going to replace x with 0. Right? If you're on the y-axis, that means the x-coordinate is 0, right? You're in line with 0 on the x-axis. So I replace x with 0 in the equation and we solve for y. Now the nice thing about this equation is that y is already alone. Right? So we have y equals already, and then negative 3/4 times 0, right? Replacing x with 0, plus 3, and then hopefully you recall that anything times 0 is 0. So this is just y equals 3. Right? So there's the y-coordinate of the y-intercept, right? So the point on the plane that we're going to plot, that's called the y-intercept of this graph, has an x-coordinate of 0, right? That's the first coordinate, comma, and then when x is 0, we see that y is 3. Right? 0, 3. And I'll put this in a box again because this is something they were asking me to find, right? So I'll circle it, right? 0, 3, one of the intercepts. And then going to the coordinate plane, 0 on the x-axis and then positive 3 on the y, right? So that's 3 up. And so that's this location here, right? On the y-axis, right? There's the ordered pair, 0 for x, 3 for y. Now, as I was saying earlier, right, this is a, hopefully, maybe you recognize this as a type of linear equation. So I can graph the line. Once you have 2 points on the plane, you should be able to graph the rest of the points. Now, if you don't see it, maybe you could plot some other points. Like if I plugged in 8, and the reason I'm plugging in a multiple of 4 is because this denominator of 4 next to the x here. So 4 goes into 8 twice. Negative 3 times 2 is negative 6, plus 3 is negative 3. Right, so this would have the point, with x equals 8 and y equals negative 3 on it. Right, there's 8, negative 3. You don't need to do this, though. Again, if you already recognize that this is a linear equation, then you only need to find 2 points. But I could do one more here. One more. If I plugged in negative 4, and again I'm trying my best to keep things evenly spaced, right? If you have graph paper it would be better. If I plug in negative 4, we're getting 3 plus 3, we're getting positive 6 for the output. So negative 4 for x, 6 for y, that looks like about this point here. And again, all these points should look like they're falling on a straight line. So 2 will be enough, right? So after this example, I'm only going to be plotting the x-intercept and y-intercept, and then using those 2 points, sketching my graph. Now you can use a ruler if you wish. I'm just going to try to eyeball a nice straight line here. Right, going down to the right forever and up to the left forever. Right, and there we go. Right, there's a graph. Oh, I forgot to label that point. Right, this has x, negative 4, and y, 6. Right? Wonderful. Right. Now, this is a hand drawing, right? Not the greatest looking thing ever. So let me show you this same equation, and I'll point out the intercepts on a free online graphing calculator. It's at a website called desmos.com, D-E-S-M-O-S. And you know what? Let me display this a little bigger so that the points pop out. All right, and I'll just off to the side here enter the equation we were given. All right, y equals negative 3/4 times x plus 3. And look, you see those gray points that are already highlighted? See, they highlight the intercepts right away. See 0, 3 on the vertical axis, the thick y-axis, right? That's the y-intercept. That's one point we found. And then the other one that's on the x-axis, see, is 4, 0. And that's, the x-intercept that we found as well. And you see the straight line running through these 2 points, right? So that's what I'm going to be doing for the rest of these linear equations examples in my video here. Just plotting the x-intercept and the y-intercept and drawing the rest of the line through it. All right, and if you'd like to see other points, you can click on the little cog here and open up a table for this, and you see a bunch of other points. See, there's -2, 4.5, -1, 3 3/4. I plugged in 8 earlier. See 8, -3. There's that point there. That was a point I plotted by hand. I plugged in -4 earlier, right? Go to the table, plug in -4 for x, and you see the output is 6, right? The value of y is 6. Right? There's -4, 6. Wonderful. All right, so it looks exactly like my hand drawing. Very, very nice. All right, so I'll clear that away, and we'll go back to my paper and move on to the next example. And we're going to be asked to do the same stuff. Find the x-intercept. All right, plug in 0 for y, solve for x. Plot that point. And then find the y-intercept. Plug in 0 for x, solve for y. Plot that point. And then we should, knowing that these are linear equations, graph the rest of the line. Now please be aware that not every equation is a linear equation. Right? If there was an x to the second power or a y to the second power or other powers, or if there were variables in denominators or special symbols, square root symbols, absolute value, whatever, just please understand that not every equation is the equation of a line. Right? Just these, though, will be. Right, so next example, another linear equation. 4 times y to the first equals 2 times x to the first minus 1. Right. So once again, I'll make a little rough hand drawing of the xy plane off to the right here. So there's the x-axis and then the y-axis. Great. All right, so let's start off with the x-intercept. So this is, again, you let the y coordinate, sorry, that's a t, let the y coordinate be 0. All right, again, if you're on the x-axis, the y coordinate is 0. So we have 4 times 0 on the left equals, and then 2x minus 1 still on the right. Now 4 times 0 is simply 0 equals 2x minus 1. And then solve for x. I would add 1 divided by 2. X equals a half, or 0.5, right, if you want a decimal. So the x-intercept has an x-coordinate of a half, right, and a y-coordinate of 0. And again, I'm going to put this in a box because this is something they were asking me to find. Right. And let's plot this point. So here's 0 on the x, and then let's say this is 1 on the x here. So half a unit would be halfway between 0 and 1. So there's half on the x-axis and 0 on the y, right? So again, you're on the x-axis. There's that point. Now this time I'm not going to label it, right, just to save on some writing. But that location there. All right, and then the y-intercept. So if you're on the y-axis, that means your x-coordinate is 0. So I replace x with 0 in this equation, then we solve for y. So we have 4 times y equals 2 times 0, and then minus 1. Right? So that's 4 times y equals, -1, right? 0 minus 1, and then we would just divide by 4 to get y alone. Right? So y equals -1/4. Another fraction, or -0.25, right, if you're writing decimals. So the y-intercept, right, has an x-coordinate of 0 and a y-coordinate of negative 1/4, right? And there's the point I'm going to plot on this graph, right? That's on the y-axis. And then again, recognizing that this is a linear equation, right? It's going to have a graph of a straight line. All I'm going to need is these 2 points, right? So there's negative 1 on the y-axis, and then negative 1/4 is, a quarter of the way down. I'm just eyeballing it. Let's say that's here, negative 1/4 on the y-axis, and so the y-intercept is here. There's 0, negative 1/4. Right, and then the rest of the graph, being a linear equation, should fall along the same line as these 2 points. Right? So a line going up to the right that way forever, and down to the left that way forever. Right? And you plot the rest of the points. Great. All right, and then just to verify that our work is good, let's go to this Desmos site. I'm going to enter this equation that we were given. 4y equals 2x minus 1. And you see the gray points highlighted there, one on the x-axis, one on the y-axis. See the x-intercept, 1/2, 0.5, comma 0. That's exactly what I had in my hand drawing. And see the y-intercept, right? On the y-axis, 0, comma, negative 0.25. That was negative 1/4. That's exactly what I had in my drawing. And then the rest of the points on this line that goes up to the right, as I had in my drawing. So it looks like my drawing was pretty good, and I verified that the points I plotted are the correct points. And again, if you want to make a table and find some other points on this, be my guest, but this is great. All right, wonderful. All right, so I'm doing the same thing every time. Same thing every time. As to find the intercepts for these, linear equations. Plot those intercepts, and then using those 2 points and knowing that it's a linear equation, plot the rest of the line, plot the rest of the graph. All right, so number 3, I got 4x minus 3 equals 2 times y. All right, so once again, I'm going to make a little hand sketch of the xy coordinate plane on the right, x-axis horizontal, and the y-axis vertical. That's not really that great looking, I apologize. Again, we'll look at the Desmos site to see a much better picture. Alright, then I'm going x-intercept first. So I'm going to let y equal 0. Replace y with 0. There's y there. So we have 4x minus 3 equals 2 times 0. That's just 0. So 0 on the right. 4x minus 3 on the left. And then you would add 3 and divide by 4. X equals positive 3/4, right? Or as a decimal, I guess I'll start writing some decimals here. That's 0.75 as a decimal. 3 divided by 4. Alright, so say here's 0, and let's go here's 1 unit on the x-axis. Now 3/4, 0.75, let's say that's about here. Again, I'm just eyeballing things. There's 3/4. And the x-intercept is 3/4 for the x-coordinate, 0 for the y-coordinate. That's the point I'm going to plot here. And here it is, right? 3/4 for the x, 0 for the y. X-intercept. Right? Cool. Okay. Then the y-intercept. Replacing x with 0. Right, I'm going to stop writing the word let. Right? So I'm going to replace x with 0. So we have 4 times 0 minus 3 equals 2 y, right? This left side is just negative 3, right? 0 minus 3 equals 2y, and then y would be equal to negative 3 divided by 2. Right? You got to divide by 2 to get the y alone, which is negative 1.5 as a decimal, but so the y-intercept has an x-coordinate of 0, right, and a y-coordinate of negative 3/2 or negative 1.5. There we go. And again, I'll plot this on our coordinate plane. So here's -1 on the y-axis, -2, and -1.5 is halfway between those, right? -3/2, -1.5, and that's where the y-intercept's going to be located, right there. And now that I have these 2 points, I recognize this as a linear equation, right? X to the first, y to the first, and no variables and denominators or special symbols. The rest of the points that satisfy this equation should fall on this line here, right? That goes up to the right and down to the left. Alright, and again, let's verify our work. You should always be checking your work. So once again, I'm just going to, off to the side here, enter the equation the way they gave it to us, right? 4x minus 3 equals 2y. And look at the intercepts, right? The x-intercept, 0.75, comma 0, 3/4, 0, exactly what I had on paper. And the y-intercept, 0, -1.5, right? 0, and then -3/2, which is exactly what I had on paper. And then the rest of the points, fall on the line with these 2 points. Wonderful. It looks like we did good. Again, you can throw a table in here if you wish, but I don't need to find any other points. Alright, let's do that again. Okay, so this one involves a few fractions, but a couple fractions, but no big deal, right? You should know how to, hopefully you know how to deal with fractions. So we have 2x minus 2/3 equals, 3/4 times y plus 3. Once again, a linear equation. Right? So all I need to do to graph it is, find 2 points, right? And those will be the x-intercept and y-intercept. Right? So there's the x-axis, y-axis for the coordinate plane. And let's start again with the x-intercept. Right, so you're replacing y with 0. Replacing y with 0. So the left side, 2x minus 2/3 equals 3/4 times 0 plus 3. So that's just 3, right? 2x minus 2/3 equals 3. Alright, then I would add 2/3. Now, remember 3 plus 2/3. Remember, you need a common denominator whenever you add or subtract, right? So this is like 3/1 plus 2/3. I'd multiply this by 3/3 to get 9/3, right? 9 divided by 3 is 3. Plus 2/3, and this would be 11/3. Right, you keep the common denominator and then just combine the numerators, right? So adding 2/3 gives me 11/3 over here, and I still have 2x on the left. And then I divide both sides by 2, or multiply both sides by 1/2. Right, that way the 2's cancel over here. I have x equals 11/6, right? When you multiply fractions, you just multiply the numerators, multiply the denominators. Alright, so this would be 11/6, which is 1 5/6, which is 1.8 and 3 repeating. 8333333. If you put it as a decimal, take 11 divided by 6. Yeah, so the x-intercept is 11/6, comma 0. That's the point I'm going to plot. And let's do that over here. So let's say this is 1 on the x-axis and this is 2. Right now, 11/6 is a little more than 1.8. Right, it's closer to 2 than it is to 1. So I'm just eyeballing things. Let's say that's there. So there's 11/6. And I'm plotting that x-intercept. Right, there it is on the x-axis. Right, 11/6, comma 0. Alright, and then for the y-intercept, remember I'm replacing x with 0. So on the left side you have 2 times 0 minus 2/3 equals, and then on the right side 3/4 times y plus 3. Alright, so the left side is just negative 2/3 equals 3/4 times y plus 3. I would subtract 3, but that's subtracting 9/3. Negative 2/3 minus 9/3 would be negative 11/3 equals 3/4 y. And then divide by 3/4 or multiply both sides by the 4/3, right? Dividing is the same as multiplying by the reciprocal. And I'm multiplying both sides by 4/3. So over here, 4's cancel, 3's cancel, right? I just got y equals negative 44/9. Negative 44/9. Which 44/9 as a decimal would be 4. That's 4 and 8/9. So 4.8 with the 8 repeating. And you can use a calculator if you want, but it's 4.888888, forever. Well, negative 4. It's negative 4.88888. So on the y-axis, here's negative 1, negative 2, negative 3, negative 4, and negative 5. Right there's negative 4 and negative 5. The y-intercept is really close to negative 5. It's almost negative 4.9. Right. So let's say it's about here. Right? There's negative 44/9. And there's your y-intercept. Oh, I guess I should also put the point, right? The point that we're plotting here. X coordinate of 0, y coordinate of negative 44/9. Right, that's the y-intercept. And there, I plot it on the y-axis there. Right? That's again between negative 4 and negative 5. Negative 44/9 on the y-axis there. And then the rest, recognizing this as a linear equation, the rest of the points should fall on the same line with these two. Right, so just kind of drawing in the rest of this line here that's going up to the right again and down to the left. And there we go. Right, little arrows indicating going in both directions forever. All right, fantastic. So yeah, working with fractions stinks sometimes, but just remember that when you add or subtract, you need a common denominator. And dividing by a fraction is the same as multiplying by its reciprocal. And when you multiply fractions, you just multiply the numerators and multiply the denominators, and then simplify the fraction if need be. Right? You can cancel common factors in the numerator and denominator if you wish, but we ended. I hope I'm assuming you know how to work with fractions. All right, and then let's verify our work here. All right. So I'm going to enter the equation back in Desmos the way it was given to me. 2x minus 2/3 equals 3/4 times y plus 3. And you see between 1 and 2 there's 1.833. That was remember I said 1.833333333. That was 11/6, comma 0. Our X-intercept, exactly what we said on paper. And then this should be, see it's 0 and then negative 4.88. Now they're rounding to 3 decimal places here. But I said it was negative 4.8888888, 8 forever, negative 44/9. So this confirms what I had on paper. Right? And then the rest of the points fall on that straight line. All right, excellent. Okay, same thing. I just got a bunch of these. Right. So another linear equation. 3x minus 2y equals 6. And you know what? I'm going to stop going to Desmos. I'll leave the checking to you. I'll leave the verifying to you from here on out. Alright, so once again, the xy plane over here. the x-intercept, remember you let the y coordinate be 0. So we have 3x minus 2 times 0 equals 6. So the left side's just 3x. You have 3x equals 6, so x must be 2 after dividing by 3. So we're plotting the point, 2, 0. So 2 on the x-axis, 0 on the y. So this point here. Again, let me put this in a little circle. And that's one of the points we were asked to find. Alright, then the y-intercept. Replace x with 0. So we have 3 times 0 minus 2 times y equals 6. The left side, you still have just the minus 2y, right, because 3 times 0 is 0, equals 6. And then I would divide both sides by negative 2, get y equals negative 3. Right? So 0 for x, negative 3 for y, right? There's the y-intercept. And here's negative 3 on the y-axis. Right? Fantastic. And now that I have these 2 points and I know this is a linear equation, the rest of the graph should fall on this same line, right? And again, we have a line that's going up to the right and down to the left. Now, please know that just because this happens for like 4 examples in a row here, doesn't mean that it's always going to happen, right? Lines can fall to the right, or be horizontal, or be vertical, or it's all sorts of other kinds of lines. All right, moving on. And again, I'm leaving it to you now to verify or get a better picture either on graph paper or with that Desmos site. So here I have another linear equation, making another xy plane. And it's not perfect, but best I can do by hand right now. Alright, so for the x-intercept, I'm just going to put x-int from here on out. We got, the y coordinate must be 0. So replace y with 0. We have x minus 2 times 0 equals 7. So clearly just x equals 7. Alright, so there's the x-intercept. Right? 7 comma 0. 7 for x. 7 on the x-axis, 0 on the y-axis. There's the x-intercept for this graph. Then for the y-intercept, right, again just y-int, I'm going to put, you replace x with 0, the x coordinate with 0. So we have 0 minus 2y equals 7. Well, that's just negative 2y on the left equals 7. And then I would divide by negative 2, so y equals negative 7 halves, or if you want a decimal, negative 3.5, right? 7 divided by 2 is 3.5. So negative 1, 2, 3, 4, there's negative 3, there's negative 4, here's negative 3.5, right? Exactly halfway between negative 3 and negative 4 on the y-axis, and that's the y-intercept. Oh yeah, I forgot to put the point, sorry. The point would have an x-coordinate of 0 and a y-coordinate of negative 7 halves, right? And we'll circle it, right? That's one of the things they're having me find. So there's your point, there's your y-intercept, and then the rest of the points, right, should being, again, recognizing this as a linear equation, rest of the points should fall on this line. And once again, please understand that not every equation will be a line, but just all the ones in this video happen to be. Wonderful. Alright, now the next equation, and again I leave it to you to verify this with a graphing calculator or Desmos or whatever. Alright, now the next equation, you're going to see that the x-intercept and y-intercept are actually the same point, and if that's the case, that means that the x-intercept and y-intercept are the origin. Right? We're going to see that here. Right? So once again, I'll make a xy plane. so for the x-intercept, right, x-int, I'm replacing y with 0. And so we have 5 times x plus 2 times 0 equals 0. That's just 5 times x equals 0 dividing by 5. 0 divided by any non-zero number is 0, right? 5 times 0 is 0. So the origin, right? The origin, the point where the x and y-axis meet, is a point on this line. And notice that, not only is the y-coordinate 0, but the x-coordinate's also 0. So what we're going to see is this is also the y-intercept, right? Remember, for y-intercept, you replace x with 0. So, I'd have 5 times 0 plus 2y equals 0, and then left side is just 2y now. Divide by 2, you get y equals 0. Oh, look at that. So the origin is also the y-intercept. Okay, well, how do you graph a line, right? Again, I know this is going to be a linear equation because you got x to the first, y to the first, and all that stuff, right? No variables in denominators, no special symbols, no higher powers, right? So I know it's going to be a line. Now to graph a line, I mentioned this already, you need at least 2 points, right? So how do I graph this line if there's only 1 point? Well, I need to find another point, right? I need to find another point to be able to graph this line. Alright, so an easy one would be to let x be, I'll tell you right now, x be 1 or 2 or 3, whatever. I'm just going to let x be 2. Just pick a value for one of the variables and solve for the other. Alright, so I'm going to let x be 2, so we have 5 times 2 plus 2 times y equals 0. This is 10 plus 2y equals 0. And just let x be something else, right, like I did here. And then we solve for y here. I'd subtract 10. We got 2y equals negative 10, right, 0 minus 10. And then divide by 2. Negative 10 divided by positive 2 would be negative 5. So another point would be x has an x coordinate of 2 and a y coordinate of negative 5. Right, and that's all I should need. Right, so I have the intercepts, right? The origin is both the x and y intercept. And then I just need to plot one other point, right, to be able to draw the rest of this line. So x is 2, and y is negative 5. And here's another ordered pair that satisfies this equation, right, 2, negative 5. And then the rest of the points, being a linear equation, should fall along the same line as these two. And finally, we're getting a line here that's falling to the right. It's going down to the right and up to the left. Oh, that was terrible. Wow. You know what? I will show you this on Desmos because that was a bad line. If I should have used a ruler or something there. All right, let me actually show you a much better picture. My apologies. 5x plus 2y equals 0, and look at that. All right, much nicer. But you see, the only the x-intercept and y-intercept is the origin, and 2 comma negative 5. If I plot that point, you see it shows up on the line here. 2, negative 5, just one other point, and then through the origin, through the point 2, negative 5, you got the rest of this line. All right, so our hand drawing is okay, even though it is a really crappy line I drew. I'm so sorry. I should have a ruler out or some sort of straight edge to make these lines better. I'm sorry. All right, just got a few more. All right, and doing the same thing every time. So example 8. Again, I'll make the XY coordinate plane, just a rough drawing. And then for the x-intercept, Remember, you're replacing the y coordinate with 0. So we have 4x minus 3 times 0 equals 12. This term will just be 0, so I'll have 4x on the left equals 12 on the right. Divide both sides by positive 4. X must be 3, so 3 for x, 0 for y. There's the x-intercept, right? So I go 3 on the x-axis, 0 on the y. There's the x-intercept right there. All right, then the y-intercept, let x be 0. So we have 4 times 0 minus 3 times y equals 12. The left side has just the negative 3y still. And then dividing both sides by negative 3, y would be negative 4. Right? So 0 for x, negative 4 for y. There's the y-intercept. Right? There's 0 for x and then negative 4 for y. There's the y-intercept. Alright, and then the rest of the points should fall on the line with these two. And again, just making it, this is a lot better looking than the last line I drew. Alright, a lot more straight. Wonderful. And again, I leave it to you to test this out. I'm not going to Desmos this time because I actually made a pretty decent line here. Right. Great. Just a couple more. Alright, so we have y minus 5 equals 5x. Again with the xy plane off to the side. Okay. Alright, so for the x-intercept, I'm going to let y coordinate be 0. So that's 0 minus 5 on the left equals 5x on the right. So that's just negative 5 on the left equals 5 times x on the right. Dividing by 5, you get x equals negative 1. And so negative 1 for the x, 0 for the y. There's the x-intercept. So negative 1 for the x-axis, 0 for the y-axis coordinate. And there it is, the x-intercept. Right, then the y-intercept, right, replacing x coordinate with 0. So we have y minus 5 equals 5 times 0. That's just y minus 5 equals 0. And then adding 5 to both sides, get y equals positive 5. So the y-intercept has an x coordinate of 0, a y coordinate of 5. There we go. Go to 5, positive 5 on the y-axis, and that's where the graph will hit the y-axis. And being, again, another linear equation, the rest of the points, the rest of the ordered pairs should fall on the same line with these 2 points here. Right? So a line going up to the right and then down this way. Right? Great. And again, I'm going to leave it to you to verify with some sort of graphing calculator or that Desmos website, whatever you want. All right, I got just one more. Just one more. Now this is maybe a funnier looking equation. Not really. I mean, you got y equals and then a fraction. The numerator has 2 terms, right? X minus 3, and the denominator has just 1 term, 2. So you can think of it as x minus 3 all divided by 2. Or, you could actually just divide each term by 2. Take x divided by 2, and then minus 3 divided by 2. Right? This is the same expression. Or you could say this is, x divided by 2 is the same as 1/2 x, right? X times a half minus 3/2. Same expression. Or if you want decimals, 1/2 is 0.5. Right? 0.5 times x minus, and then 3/2 is 1.5. Right? But all 4 of these are the same expression. So it depends on what you like better. Alright, so I'm going to again graph this. It's still a linear equation. Right? You have x to the first, y to the first, no other powers of x and y, no special symbols, no variables and denominators. Right? This is still a linear equation. So I'm making the xy plane here again. Alright, Now for the x-intercept, again you're replacing the y-coordinate with 0, so we're solving this equation. 0 equals x minus 3, divided by 2. Well, to get rid of the divided by 2, you multiply by 2. Well, 0 times 2 is still 0, and then timesing the 2 on this side gets rid of the 2 in the denominator. You have just the numerator left, just x minus 3. And then add 3. Right? X would be equal to positive 3. So 3 for the x, 0 for the y. There's the x-intercept. So I go positive 3 on the x-axis. There's where the graph is going to be on the x-axis right there. Plot that point. Alright, and then the y-intercept. Right, I'm just going to replace the x-coordinate with 0. So again, this original equation, we have y equals 0 minus 3 in the numerator, 2 in the denominator. That's just negative 3 in the numerator, 2 in the denominator, and y is already solved for. So y equals negative 3 halves, or negative 1.5 if you want a decimal. So 0 for the x, negative 3 halves, or negative 1.5 for the y. There's your y-intercept. So here's negative 1, here's negative 2, and then the y-intercept is at negative 1.5, negative 3 halves, right? Halfway between negative 1 and negative 2 on the y-axis. And now I have the 2 points I need to be able to plot the rest of the line, right? Again, I recognize this as a linear equation. So the rest of the points that you find should fall on this same line with these two. And there we go. And again, I leave it to you to go to that Desmos website, some graphing calculator, whatever, to really double check and verify that the points we found here, the x-intercept, the y-intercept, are proper, are actually working, or just plug in that value of x, plug in that value of y, plug in 3 for x and 0 for y, and see that you get a true statement. And do the same thing for 0 for x and negative 3 halves for y, and see that you get a true statement, right? But you should be verifying your work, checking your work, double checking your work, before you hand things in, right? You gotta want to make sure you're doing things properly, doing things the right way. And great. All right, so a lot of the same stuff here, right? I'm hoping that watching me go through these 10 examples, helps you in some way when you're asked to, take a linear equation. And you would do this with any equation, really, if you're asked to find the intercepts, right, for any equation involving x and y. For the x-intercepts, you plug in 0 for y, solve for x. For y-intercepts, you plug in 0 for x and solve for y. So I'm hoping that watching me go through these 10 linear equations anyway helps you when you're asked to find intercepts and plot points on your own. And thank you very much for watching.